In this lesson, we will begin our discussion of specific measurement-related issues concerning the reliability and validity of the information that we have collected as part of our assessment or research process. Now, as we begin to examine reliability and validity, we can also introduce a new term which is traditionally viewed within the research field, but is also relevant to the classroom situation. And that is simply a discussion about instrumentation. Whenever a researcher is referring to instrumentation, they are simply referring to the tool that is being used to capture the quantitative information. In classrooms, this is commonly going to be achievement tests. Within research, this can be expanded to include things such as personality inventories, attitude surveys, etc. Now, as was mentioned at the beginning, the two primary issues that not only a researcher but also a classroom instructor should be concerned with is the reliability and validity of the information that is being collected. And in particular, reliability addresses or is concerned with the consistency of the information that is being collected. And validity, on the other hand, is concerned with the accuracy. So reliability, when we begin that discussion, basically we're concerned with the notion of if an instrument is used repeatedly on the same individual, are we getting the same results back? Assuming we haven't done anything between the first administration and the second administration to cause the performance to change. Likewise, with validity, what we're ultimately concerned with is when we get the numerical score, is this score an accurate reflection of true performance? In other words, when we administer a test and an individual scores an 80, then is that score truly reflective of that individual's knowledge concerning that particular content? And again, as was mentioned in an earlier lesson, if these two characteristics are not supported through your instrumentation, then you begin to raise concerns about the quality of the information, and consequently that will lead to questions regarding the quality of the findings and ultimately lead to a questioning of the decisions that get made based on those results. Now, if we look at the relationship between reliability and validity, then we will first see that reliability is necessary but not sufficient for validity. This is often described in the analogy of building a home or some other type of structure, where the first thing that must be done is a foundation must be poured or formed. Without the foundation, the building cannot be constructed. However, it's possible to have a foundation and never construct the building on top of it. That analogy applies directly to reliability, because when we are looking at the relationship, it is possible for a measuring instrument to be reliable, in other words, yield consistent results, but yet those results aren't accurate. So at the same time, it's not possible to have accurate results when we can't even establish consistency. We can also see this illustrated through a series of results of target shooting. And in our first illustration, we have a result pattern where all of the shots are first clustered close together, which would suggest a certain level of consistency. And then secondly, they're also on target, which suggests a high level of accuracy. So when these two issues are looked at collectively, then we would reference this first target or describe this first target or the first individual as being a valid and reliable shooter. The second result pattern we see is somewhat scattered. So there really doesn't appear to be any consistency. Right? Consequently, because of the lack of consistency, then any discussion of accuracy is really inappropriate, because out of all of the shots that were fired in this particular instance, only one struck the bullseye. So accuracy in this instance really becomes a non-issue. In our third example, we have a situation where, once again, the results pattern shows a clustering, and therefore we have a certain level of reliability, but because the items are not on target, then we really don't have a high level of accuracy. So again, when you look at the three different illustrations, you can begin to see the underlying relationship between reliability and validity. From a discussion standpoint, it really becomes a sequential discussion. The first focus must be on reliability, while the second focus then becomes validity. And until you have evidence to support an acceptable level of consistency, then any discussion of accuracy is simply not relevant. Now, up to this point, we have simply referred to reliability and validity as consistency and accuracy. Within the area of reliability, there are actually a variety of types, such as inter-rater, inter-observer, stability, equivalency, and internal consistency. And each of these types has a specific process that can be used to establish a given level of reliability. And each is used for a specific situation. Likewise, with validity, there are a variety of types, if you will, of validity. Content, which is most appropriate for dealing with achievement tests. Construct, which extends more into things such as personalities or attitudes that we can't necessarily measure very directly, but yet we're still attempting to get some sort of numerical representation. Now, if we take a closer look at the types of reliability, inter-rater and inter-observer reliabilities are generally used in non-traditional testing situations. In other words, inter-rater reliability, for example, is used typically when someone is grading essays. And in order to establish consistency, we're really establishing consistency between the individuals who are reading and scoring the essays. Inter-observer is a similar issue in that the consistency is still between the individuals doing the data collection. In this instance, the individual may be making observations within a classroom, and in order to establish credibility within the data, then you want to have perhaps two people doing observations and establish that both people, if exposed to the same situation, would record the same observations. This is most easily accomplished when the recording instrument is something like a checklist, where each individual could be trained on the specific behavior to look for, and so once they've reached a certain level of training and a certain level of agreement, then a researcher would have confidence in knowing that it did not matter which observer went out into the classroom, the other one would have brought back the same type of information. Now, when dealing with a classroom situation, the relevance to this is not really that much different. If you are looking for specific behaviors to be occurring within a classroom, again, you want to know clearly what kind of definition you have for that behavior. And while you may not go through the formality of bringing a second person in just to kind of give you that added level of assurance that you really are observing what you think you're observing, the issue is still pertinent to a classroom. Now, the other three issues that were mentioned previously, stability, equivalency, and internal consistency, are generally used in situations where you have traditional objective tests. And by objective tests, we're really talking about things like multiple choice tests, true-false tests, matching tests, things where basically items are easily graded right or wrong. There's very limited subjectivity involved. And when someone is interested in stability, what they are generally interested in is what people would refer to as test-retest reliability. And the idea behind an instrument producing stable data is simply, if you give an instrument to a class or a sample and score that instrument and then return at a later time, re-administer that instrument and score that instrument, then the scores really should not change. They should basically remain stable. Now, it is important to understand that when working with something like a test-retest reliability, in order for this to work correctly or work properly, then what occurs between the first administration and the second administration should not be something that would affect their performance. In many instances, a researcher may, for example, give a pretest, or an instructor may give a pretest to see where the classes stand with regard to their performance, and then at the end of the unit, obviously they give a post-test. But to compare the pretest to the post-test in terms of reliability is simply not relevant, because instruction took place between those two times that's designed to alter performance on the assessment. Equivalency is a form of consistency that is relevant when a researcher or an instructor is utilizing multiple versions of one instrument. A classroom instructor, for example, may have created two versions of the test in an effort to minimize cheating within the classroom. But if that is going to be done, then the classroom teacher needs to have a high level of confidence that regardless of which version of the test an individual student received, their results would have been the same, or their results would have been consistent. So equivalency, again, is only relevant in situations where you have multiple versions of a test. Internal consistency, which is the final type of reliability that we will discuss, basically is relevant in situations where you're administering a test on one occasion and you are only working with one version of the test. So in some respects, it can be viewed as a catch-all situation. And generally speaking, internal consistency is simply going to be determined through the use of a standard formula. Some of the more common approaches would be a Kuder-Richardson formula or a Cronbach alpha technique. Now, before we progress into the discussion of validity, it's also important to re-examine our research process to understand why reliability is truly important. And again, we discussed earlier in one of the opening lessons about the parallels between research and classroom instruction. And remember, ultimately, both assessment and research boil down to a process that ultimately is designed to assist with decision making. And so if we take a quick look at the research process where we've identified our sample, collected and analyzed data, and then attempted to make decisions, then what many people often do is get to the reporting results and making decisions and then attempt to simply take these results and apply them directly back to the population, almost as if this is a circular pattern. However, the pattern that occurs should actually backtrack through the process that was used. So, in other words, once the results have been obtained, then in order to make the decision, the process must first be evaluated. So, for example, the analysis that was used, or the tool that was used, if we go back to the original definition of statistics, was the correct tool used to analyze our data, right? And if it was, and we did identify our results as statistically significant and therefore ruled out chance as an explanation, then as far as the analysis step, we feel like, okay, we did that step properly. So then we can back up and begin to look at, okay, did we collect our data in a good way? And so we begin to look at the process of how we went out and collected data. But as part of that examination, we need to look at things like the reliability of our assessment process as well as the instrument. And so if we go back through and we examine and we see that, well, our reliability wasn't that strong, then that will in turn begin to question the actual results we got, and therefore call into question how confident we can be when we actually begin to make decisions. So in saying this, we can see how the manner in which our data is collected, and in particular whether the data is reliable and valid, will in turn impact our ability to make decisions once we have actually subjected our data to the analysis. Because after all, when we enter numbers into the computer does not know whether the numbers are of good quality or not. The computer is simply going to run the analysis that we request. And so it is up to the researcher or the instructor to determine whether the data being collected is of good quality. So having discussed reliability, we can begin to conclude this discussion with a quick look at some of the styles of validity, and in particular content validity, which is going to be most relevant to classroom instruction, because this is generally related to achievement. And content validity simply deals with the notion of, does the content of our assessment or our instrument, does it match what was covered during the instruction? And the establishment of content validity might simply involve taking the exam that has been developed and having it reviewed in light of the lesson plans that were developed. And so we have some sort of set of standards that says either this is what should have been covered or what was covered, and then we basically take and compare, is that in turn reflected within our instrument. Construct validity can be viewed somewhat similarly. The major difference is we're going to be dealing with issues that maybe aren't as directly observable, things like attitude, things like personality, but in concept it is similar to the achievement situation or the content situation, in that ultimately we want to be able to take our instrument, have it reviewed, and ultimately content and construct become much more of a judgmental decision than an actual numerical decision. Because one of the issues that is consistent through all of the reliabilities is that they are quantifiable estimates, meaning every form of reliability will produce a numerical estimate that can then be compared or judged in terms of whether it is acceptable. Was it high enough to be acceptable? Content and construct validity are simply more of judgment decisions than a true quantifiable decision. Predictive and concurrent validity are two types of validity that often are associated with test development and are situations where an individual may have developed a new instrument and they're wanting to establish the accuracy of it, and they may do that through basically comparing it to an existing instrument, which would be a concurrent approach, or if they're interested in seeing if their new instrument predicts performance on some other instrument, then obviously that would be an indication of predictive validity. Again, the underlying issue with all four approaches is simply we're wanting to be able to have an instrument that accurately does the job it's supposed to do, whether it be to predict, whether it be to measure the same thing as another instrument, or whether it be to simply accurately reflect the content that was covered during instruction. But just like with reliability, having accurate information improves the quality of our results, and therefore the analysis that we use is going to be based on higher quality information and will in turn give us stronger results, results in which we're more confident with, and so we can hopefully make the most effective decisions. Now, as far as some final characteristics with regard to reliability and validity, In both cases, these two characteristics are considered to be a matter of degree. And the strongest illustration of this was the reliability example, and in particular with the middle or the second of the three targets that we used in that illustration, because that particular target had results that were scattered, across all rings of the target. And so even though relative to our discussion we would indicate that it was not reliable, the truth is it was reliable. It was simply to a much lesser degree than the other two targets. And so whenever you talk about reliability and validity, then everything always has a certain amount of consistency. Everything always has a certain amount of accuracy, but the question becomes, is it strong enough? Is the degree of consistency acceptable, high enough, so that we are willing to use it for instructional decisions or conclusions with regard to our research, etc. The other issue to remember with reliability and validity is they are specific to individual groups. And this is very important when you are considering the selection of an instrument, whether it again be to use in a classroom or in a research study. If you identify an instrument that already exists and the publisher has reported the reliability and validity, if that reliability and validity was established on college students, but you want to use this instrument with high school students, then it's important to understand that those estimates and any comments regarding reliability and validity may not transfer to this other group because it is a different age group, and that the population that you're wanting to use does possess different characteristics. And finally, validity is specific to the interpretation. And what that really means is an instrument, when it is developed for a very specific purpose. And so when an instrument is described as valid, it is valid for accomplishing that specific purpose. And so if you intend to use an instrument for a different reason, then again, any prior comments regarding validity may simply not be relevant.